Hello, in this video we're going to take a look at a couple of examples of applications involving systems of linear equations. Alright, so in one year there was a total of 34 commercial and non-commercial orbital launches worldwide. In addition, the number of non-commercial orbital launches was 4 more than twice the number of commercial launches. Determine the number of commercial and non-commercial orbital launches. All right, so the first thing that I always recommend you doing is figuring out what the question is asking you to find, because that's going to tell you what your variables need to represent. So we're going to let x be the number of commercial launches, and we'll let y be the number of non-commercial launches. All right, we know there were a total of 34 worldwide, so that means x plus y have to add up to 34. And they said the number of non-commercial orbital launches, well, that's our y value, was, anytime you see the word was or is, that's going to translate in math to an equal sign. 4 more means 4 plus that number, more than twice the number of commercial launches. Well, that's twice our x value. So there's our system of equations. This one's set up pretty nice to use the substitution method, so we could just plug right in. So we'll get x plus, instead of y, we're going to have 4 plus 2x equals 34. That's going to give us 3x plus 4 equals 34. Subtract that 4 from both sides, and we get 3x equals 30. So x has to be 10. And then if we plug that back in, we can find our y value. Y is going to be 4 more than 2 times 10. And so we get y equals 4 plus 20 is 24, so that means there were 10, our x value was commercial launches, and there were 24 non-commercial launches. You can check this using your calculator. Using the RREF. And so there's a couple of different ways to do it. If you have a TI-84, you want to go to second and then your matrix, which is right below your math, and then scroll over to the math menu and select RREF. It's going to be at the bottom of the list, so it might be easier to go down instead of up. And then once you get back to your calculation screen, you're going to do alpha zoom, and our equations here, we do need to rearrange it so that we've got it in the form of x, y equals and constant. So I'm going to go ahead and subtract this 2x to get it on the other side, plus our y equals 4. So we want to make sure that we've got our x's, our y's, our equals, and our constants all lined up there. And then we're going to plug in. That's matrix is going to have 2 rows because we have 2 equations. And then we've got 3 sets of numbers. We've got our x's, our y's, and our constants. So that's going to make it a 2 by 3 matrix. And we're just going to put our numbers in. So we've got 1x, 1y, and 34 constants on our first equation. And then negative 2x, 1y, and 4 on our second equation, and we do get that our 1x, because x was the numbers we put in first, equals 10, and then 1y equals 24. All right, let's do another one. So this one we have a Broadway theater has 400 seats divided into orchestra, main, and balcony seating. Orchestra seats sell for $60, main seats for $50, and balcony seats for $30. If all the seats are sold, the gross revenue for the theater is $18,200. If all the main and balcony seats are sold, but only half of the orchestra seats are sold, the gross revenue is $15,800. How many of each kind of seat are there? So again, just like we saw in the previous one, the question of what it's looking for is going to tell you what your variables are going to represent. So how many of each kind of seat are there? So let's let orchestra be represented by an O. M is going to be the number of main seats, and B is the number of balcony seats. So we know altogether there's 400, so that means O plus M plus B has to equal 400. We know that the orchestra seats sell for $60, main for $50, and balcony for $30. And if all the seats are sold, the revenue is $18,200. Here you want to make sure that you are matching up units. So dollars plus dollars has to equal dollars, and seats plus seats has to equal seats. So make sure, pay attention to your units. If you can get your units matched up, these should be pretty easy. All right, so if all the seats are sold, the revenue is $18,200. Well, for every orchestra seat, we're going to get $60. So we'll get 60 times O plus $50 for each main seat plus $30 for each balcony seat has to add up to $18,200. And if all the main and balcony seats are sold, but only half of the orchestra seats are sold, so we're going to get half of our orchestra seats at $60 a piece, and then all of our main and all of our balcony seats, then our revenue is $15,800. Let's go ahead and simplify this just a little bit, make sure we have everything lined up. Our orchestra, our main, our balcony, our equals, and our constants all lined up. So we're going to get orchestra plus main plus balcony equals 400. And then we get 60 times our orchestra plus 50 times main plus 30 times balcony equals 18,200. If you want to, you could divide all of those by 10, make the numbers a little bit smaller, but we're going to use the calculator to solve this one, so it doesn't care what size the numbers are. All right, simplifying this last one, we're going to get half of 60 times our orchestra seats, so that's going to be 30 times our orchestra, plus the 50 times the main, and the 30 times our balcony is going to be 15,800. And so now we're going to do the same thing we did on the calculator just a minute ago. We're going to go to our matrix menu, and we're going to scroll over to Math, and scroll down to RREF, Reduced Row Echelon Form is what that stands for. And then we're going to do Alpha Zoom. This one we have 3 equations, so we're going to have 3 rows. And here we have 3 variables plus our constant, so we've got 4 sets of numbers. So we're going to get 1 orchestra, 1 main, 1 balcony is going to equal a total of 400 seats. And then if we get $60 times our orchestra, $50 times our main, $30 times our balcony, we get 18,200. And then $30 from our orchestra seats, $50 for our main, $30 for the balcony, and then 15,800 for our revenue. In that case, we get that our matrix is going to be 10080, 010 190, and 0, 0, 1, 130. So remember, our first set of numbers came from our orchestra, so we've got one orchestra, so our O equals 80. Our middle row there was our main seats, and that is 190, and then our balcony was 130. So that means we have 80 orchestra seats. 190 was the number of main seats, and 130 is the number of balcony seats. All right, I'll see you guys next time.